You have got to see these photos. NASA just dropped some of the most stunning, most detailed pictures of our universe we have ever seen. And it's all thanks to the brand new James Webb Space Telescope. And yeah, they're beautiful, but they do more than that. They bring us closer than we've ever been to answering one of humanity's oldest and biggest questions.
Are we really the only ones out here? You know, it's the ultimate question, right? It's what drives us to explore the cosmos. And this telescope, the James Webb, it's our most powerful tool yet in the hunt for an answer.
And with this incredible new tool online, humanity's greatest detective is officially on the case, searching for those telltale signs of life beyond Earth.
Now, to really get what this thing can find, we first have to appreciate what an incredible piece of engineering it is. This is not just another telescope.
I mean, the scale of this project is it's hard to wrap your head around. We're talking $10 billion, 25 years to build, and it's parked 1.5 million kilometers away from us. And get this, to detect the incredibly faint heat from distant galaxies, the telescope itself has to stay unbelievably cold. We're talking minus 266 degrees Celsius. That's just a few degrees shy of absolute zero, the coldest possible temperature in the universe.
But here's the kicker. The telescope's real power isn't about the light we can see with our own eyes. No, its superpower is its ability to see the invisible universe.
So how does it do that? Well, it sees the universe in infrared light. Just think of infrared as a color of light that our eyes simply can't pick up. And the crucial thing is, because its wavelength is longer, it can sail right through these enormous thick clouds of cosmic gas and dust that would normally block our view, showing us all the secrets hidden inside.
So, the telescope basically has two main sets of infrared eyes. The first one, NIRCam, sees in near infrared. It's perfect for capturing all the breathtaking, fine details within those cosmic clouds. But its other instrument, MIRI, sees in mid-infrared, an even longer wavelength. This lets it peer right through the dust. And this gives us two totally different views of the same object, as you're about to see.
And this brand new way of seeing the universe, it allows us to witness the entire grand cosmic drama of how stars are born and how they die.
Okay, take this for example. This is the Southern Ring Nebula, captured by that first camera and IRCAM. What you're looking at is the beautiful final act in a star's life. For thousands of years, this dying star has been puffing off its outer layers of gas and dust into space.
But watch this. Watch what happens when we switch over to the MIR camera. The dust cloud basically becomes transparent, and boom, a second star pops into view. It was there the whole time, a brighter companion star, but it was completely hidden by the dust. This just perfectly shows the power of being able to see in these different wavelengths of light.
And what's wild is that this is the fate waiting for stars just like our own sun. In about 5 billion years, our sun will swell up into a red giant. Then it'll shed its layers, creating a nebula just like this one, leaving only its tiny, dense core behind, a white dwarf.
But hey, for every ending, there's a new beginning, right? The telescope also gave us this, just absolutely jaw-dropping image of the Carina Nebula. These cosmic cliffs are what's known as a stellar nursery. The clouds of gas and dust here are collapsing in on themselves, forming brand new stars. We are literally watching stars being born.
Okay, so seeing through cosmic dust, that's one superpower. But its other one is even more mind-bending. By capturing light that has traveled through billions of years, the James Webb Telescope is quite literally a time machine.
Take a look at this. This is the telescope's first deep field image. Now get this. Every single speck of light you see here isn't a star. It's an entire galaxy. And since that light has taken billions of years to reach us, we're seeing some of these galaxies as they looked over 13 billion years ago, right near the dawn of the universe itself. So how can it possibly see so far back in time? Well, it uses this incredible cosmic cheat code called gravitational lensing. The massive gravity of the galaxies in the foreground actually acts like a giant magnifying glass. It bends and amplifies the light from even more distant galaxies that are hiding behind them. It's a natural telescope built into the very fabric of space-time.
Looking back to the dawn of time is absolutely amazing. But let's be honest, probably the most exciting part of this whole mission is using this technology to search for the building blocks of life on planets orbiting other stars. But how in the world do you do that? How do you find something like water on a tiny little planet, a dot you can't even see directly, from over 1,000 light years away?
Well, the answer is surprisingly simple, and it starts with a leaf.
Why is a leaf green? Well, it's because the stuff inside it, chlorophyll, it absorbs red light and blue light from the sun, but it reflects the green light back at our eyes. So we see the color that isn't absorbed.
Okay, so let's apply that same exact logic to a planet. When light from a star passes through that planet's atmosphere, different molecules in the air are going to absorb very specific wavelengths or colors of that light. And on the exoplanet WASP 96b, the telescope spotted a very specific dip in the light spectrum, the unmistakable chemical fingerprint of H2O, water.
We found water. So that's it, right? Case closed, we found aliens? Well, not so fast. While this is an incredible achievement, WASP 96b is a giant gas planet with a surface temperature over 530 degrees Celsius. So yeah, definitely not a home for life as we know it.
But that was just a test run. That was the warm-up act. Now, the telescope is turning its attention to a much more promising candidate. Meet TRAPPIST-1e. And just look at how eerily similar it is to our own world. Its radius, its mass, its gravity, and the fact that it has a solid rocky surface. It's one of the most Earth-like planets we have ever found.
So we know it has a solid surface. Check. We know it's in the sweet spot, the habitable zone, where liquid water could exist. Check. The last big piece of the puzzle is its atmosphere. And over the coming months, the Webb telescope will be analyzing that atmosphere, looking for that key mix of gases, things like carbon dioxide, methane, and water vapor, that could be a biosignature, a real sign of life.
We've got the recipe, and we finally have a tool powerful enough to check for the ingredients on another world. For the first time in human history, this is possible. The search has only begun. The real question is, what are we going to find?